Okay, factoring polynomials completely. Really, this lesson first gives us practice with factor by grouping, and then it moves into reviewing all the concepts that we've studied with factoring. So, factor by grouping. So first, when a polynomial has 4 terms, okay, so I'm going to just go check by check on this. When a polynomial has 4 terms, so for instance, if I look at this first one, 1, 2, 3, and 4, the process of grouping polynomials in pairs of terms. So grouping in math, we group using parentheses. So I'm going to make 2 pairs here, and I'm just going to pick that. Those are the first 2, and these are the next 2. So I'm just going to put parentheses around them. Okay. Now there's more that goes into that thought eventually, but for now, that's all I'm doing. Okay. I'm going to try those 2 groups. So the process of grouping polynomials in pairs of terms and factoring out a greatest common factor from each pair. Okay. So greatest common factor, well, greatest common factor of x cubed and 4x squared, well, numerically nothing goes into it other than 1, but x cubed and x squared goes into it. Okay, and so what I'm going to do is I'm going to take that x squared out of there. Okay, and then I'm going to switch colors here real quick, and I'm left with x squared times what is x cubed? Well, that is x, and x squared times what is 4x squared? That is positive 4. Okay, and then on the next one, what comes out of 2 and 8 is 4. So plus 4. All right, and this has an x, that one doesn't, so we can't do anything with that. But 2 times, I'm sorry, that's not right. What goes into 2 and 8? Let's try that again. What goes into 2 and 8 is 2. Excuse me there, for those of you who are like yelling at your screen. Okay. And 2 times what is 2x? That is x. And 2 times what is 8? That is 4. Okay, and I'm going to put there, stick with the color coding there. Okay, so we factored out a common monomial from each pair. All right, then looking for and factoring out a common binomial. Binomial means 2. So when I look at these 2 pairs, so note I have a pair right here that I factored out a monomial, and I have a pair here that I factored the monomial out. Okay. Well, when I look at those 2 pieces, notice they have in common x plus 4, right? They have that x plus 4 in common. So what I'm going to do is I'm going to make that my common binomial factor. It's almost like it's taking out a greatest or a common factor from each. When I take out an x plus 4 from this, I'm left with x squared. And when I take an x plus 4 out of this, I'm left with that plus 2. And that becomes my other quantity. I have now completed factor by grouping. Notice I have x plus 4 times x squared plus 2. I am now multiplying 2 things together, no longer adding multiple things. Okay, let's try another one here. So I have 4 terms, 1, 2, 3, 4. I should still look for greatest common factor. No greatest common factor comes out. So I'm just going to try groups. And once again, I'm going to try just the first 2 groups that I see. There's a group and there's a group. What goes into 12 and 9? Well, what goes into 12 and 9 is 3. What goes in x cubed and x squared? Well, x squared. We always take the one with the smaller degree. So 2 is the smallest degree. All right. And what am I left with? Well, let's switch colors here. 3 times what is 12? That's 4. X squared times what is x cubed? That is x. 3 times what is negative 9? That's negative 3. And x squared times what is x squared? Just, we don't need any more there. Okay? All right. And then 4 and 3, nothing goes into it. And x and nothing. Okay? So really what I have is I have this 1 hanging out front here. And I'm left with just 4x minus 3. And outside of that, I have that plus 1. All right. So now, I look for the common binomial. Notice that's the 4x minus 3. I bring that down. And what I have left is the 3x squared plus 1. And that 3x squared plus 1 becomes my extra parenthesis. I've now finished factor by grouping. Now there's more things you should check for after that, and I'll show that in the next slide, but for now, let's call it good there. Okay, I put this next one on here just because when I make my groups, if I go this group and say this group, now you may not want to do that yet. Notice when I started this out, I had a negative 8x, and when I put a parenthesis around here, now I have a positive 8x. And this minus 20 no longer is minus because you distribute it and it becomes a plus 20. So I guess I'd have negative 8x plus 20, which I don't want. So what do I need to worry about? Well, anytime you see a minus in there, you should really start thinking, well, I'm going to rewrite it. So 2x cubed plus 5x squared, and I'm going to put plus negative 8x minus 20. So I'm just saying I'm going to add a negative 8x minus 20. Okay? And so really when I set my groups now, I have that group and I have that group, and it's a plus in between. You always want to have a plus in between the parentheses, just like we did in the previous two. So we haven't changed its value. So let's actually, before I switch colors here, let's go ahead and look at what can I take out of 2x cubed and 5x squared. Well, that would be x squared. No numbers. So x squared times what is 2x cubed? Well, that would be 2x. And x squared times what is 5x squared? That would be 5. And then what can I take out of negative 8x and negative 20? Well, looks like negative 4. Okay, and negative 4 times what is negative 8x? That would be 2x. Negative 4 times what is negative 20? That would be positive 5. So what am I left with? Well, I have the 2x plus 5. That's common. And then I'd have the x squared minus 4 afterwards. Now, notice I said, hey, there's more that you might have to do. Well, notice this right here, this 2x plus 5, I can't do anything with it. I can't take out a greatest common factor. It's not the difference of two squares. However, this is the difference of two squares. Notice x squared minus 4, that becomes x plus 2 and x minus 2. So we have to keep factoring there. Okay, and I'm going to make that more clear on things we look for on our next slide here. But yeah, now we have factored it completely. Okay, so this x squared minus 4 use difference of two squares on. Okay, so let's go through and talk about that just really quick. All right, our factoring guidelines. First thing we want to do is we want to factor out a greatest common factor. So anytime we have a problem, so for instance, let me go back there. Let's say I have 3x squared minus 6x. Okay, taking out a greatest common factor, well, I'd take out 3x. 3 times what is 3x squared? Or 3x times what is 3x squared? That would be x. And 3x times what is negative 6x? That would be minus 2. There's an example where you take out a greatest common factor. Okay. After you take out a greatest common factor, you want to count the terms. So we just kind of have a checklist here. The next thing is we count the terms. So if there are two terms, we're going to look for difference of two perfect squares. So for instance, we have x squared minus 16. There's two terms, perfect square, and difference. So that becomes x plus the square root of 16, which is 4, and x minus the square root of 16, which is also 4. All right. And so the next step, if you had three terms, we would use what we call form factoring or general factoring. For if you're going with what I taught, that's where we kind of, let me leave that there, that's where we use that x, right? And so maybe we have 2x squared minus 7x plus 5, okay? And we said, well, a times c is 10, b is negative 7. Two things that multiply to make 10 and add to negative 7 are negative 5 and negative 2. And so that becomes x minus 5, x minus 2. And then we have to divide by our a term and reduce. Okay, so you can't reduce 5 halves. Okay, so that 2 drops in front. So we get 2x minus 5. And we can't reduce, or we can reduce this. This becomes 1, so it becomes x minus 2 divided by 2 is 1. And now we factor that. And then lastly, if there are four terms, you actually do factor by grouping. So let's say we have, let's do 3x cubed and minus 8x squared plus 6x minus 16. Okay, two things that multiply, or excuse me, making two groups here. And by the way, it won't always just be the first two like that. Sometimes you have to rearrange the terms to make your groups. All right. But what goes into 3x squared and 8x squared? Well, x squared. X squared times what is, I'm sorry, that's 3x cubed. X squared times what is 3x cubed? That's 3x. X squared times what is negative 8x squared? That would be negative 8. And what goes into 16 and 6x? Well, that would be 2. 2 times what is 6x? That's 3x. And 2 times what is negative 16? That's negative 8. And so now I have the common piece, 3x minus 8. And I have the leftovers, x squared plus 2. Okay, and I am done. Now, kind of the reality is here, what happens is you always look for greatest common factor, and then you count the terms. And if you have 4 terms, you have to do factor by grouping, and then there's a chance you maybe have to do some form factoring or difference of 2 squares. If you only have 2 terms, you won't have to ever work your way down the list, but you may have to work your way back up the list. Okay? All right. So let's go ahead and try another problem here. Factor completely. All right. So first thing I do is always look for a greatest common factor. So does anything go into x cubed, x squared, and 6x? Okay. Well, looks like x does. X times what is x cubed? That's x squared. X times what's negative x squared? That's negative x. And x times what is negative 6x? That's negative 6. Okay. And now I look at my parentheses, and what I need to do, think back, count your terms now. If there are 3 terms, look for form factor and keep referring to this list. Okay, so there are 3 terms here. These 3 terms I look for form factoring. So are there 2 things that multiply to make 1 times negative 6 or negative 6 and add to negative 1? And yeah, there are. It's negative 3 and positive 2. Okay, so bring this x down. And then inside the parentheses, I have now x minus 3 and x plus 2, right? These pieces. Okay? And I divide by a, but a is 1, so nothing happens. There we go. We're done factoring. Really, what we should do before I say we're done factoring, notice you have 2 binomials now. And so there's 2 terms. And remember, with 2 terms, you're looking for difference of 2 squares. So we started here. We should really check here next. Difference of 2 squares. Perfect square? No. Perfect square? No. So we're done. All right, let's go ahead and try another one here. So greatest common factor of 4 and 36. Well, that's 4. X cubed and x. Take the one with the smaller degree, which is x. 4x times what is 4x cubed? Well, that's x squared. 4x times what is negative 36x? Well, 4 times negative 9. We already have the x. Okay, and so now we count the terms. 1, 2 terms in our parentheses. Well, 2 terms is difference of 2 squares. Okay, well, is this a perfect square? Yes. Is this a perfect square? Yes. Is this a difference? Yes. So we take the square root of the front. That's x. Square root of the back. That's 3. And we have x plus 3, x minus 3. And then you should really count your terms again. 1, 2, 1, 2. Look for difference of 2 squares again. Perfect square, nope. Perfect square, nope. So we are done. All right. The next one here. Look at it. Greatest common factor. Well, 10, 80, and 160. Looks like 10. X cubed, x squared, and x. Well, looks like x. 10x times what is 10x cubed? That is x squared. 10x times what is 80x squared? That is 8x. 10x times what is 160x? That is 16. Count the terms. 1, 2, 3. 3 terms means I need to check for form factoring first. So look at this and we go, okay, well, 2 things that multiply to make a times c, or 1 times 16, or 16, and add to 8. Well, that would be 4 and 4. So this becomes x plus 4 and x plus 4, and we bring the 10x down. Divide by a, which is 1, it won't matter. Binomial, binomial, well, you're looking for difference of two squares. Perfect square, nope. Perfect square, nope. So we are done. You can either write it as this, or since x plus 4 is the same, you could say it's x plus 4 quantity squared. So 10x times x plus 4 quantity squared. Or that one. Either one would work. All right. Now please note the directions here say factor completely. They don't say solve. These say solve, right? And notice the difference between a solve and a factor completely. A solve has an equal sign, whereas a factor completely doesn't. You can only solve equations with equal signs. Notice I put our steps here so we don't have to keep referring back. But first step, anytime you're going to solve, you may want to make a note of this. Whenever you're solving, you need to make it equal 0. Okay? So this doesn't equal 0. So the first step is to make it equal 0. So 3x squared minus 24x. And how do I make it equal 0? So, well, I'd have to add the 48 over. So plus 48 equals 0. And now from there, I just move into factoring. Okay, that's the only way I can solve. So greatest common factor of 3, 24, and 48. Hopefully you're getting the habit. Just go greatest common factor first. Well, looks like 3 goes into all of those. 3 times what is 3x squared? Well, that's x squared. 3 times what's negative 24? That's negative 8. X. And 3 times what is 48? That is 16. 3 terms. 3 terms is form factoring. That's where we use the x, remember? Okay, so I look at that and I go, okay, well, 2 things that will multiply to make 16 and add to negative 8. Very similar to the previous problem, except for this time it's negative 4 and negative 4. So we have 3, we have x minus 4, and x minus 4 equals 0. Binomials, so 2 terms, so we got to work our way back the list here. 2 terms. Perfect square? Nope. Perfect square? Nope. Almost. If this was an x squared, we'd have to keep going, but can't do anything else. So now we just look at solving. This has an x, this quantity, so x minus 4 equals 0 when x is 4. And here, this is the exact same problem. So it's going to also be when x equals 4. So the solution here is x equals 4. It's a repeated solution, and when we get to graphing it, you'll see that that's actually where our graph turns. We'll talk about that later. Notice once you start with 3 terms, you've got to work your way up to 2 terms. If you were to starting here at 4 terms, you should check 3 and then 2. If you start at 2, you're like, oh, there's 2 terms. You'll never have to work your way down the list, which is good. Okay? So if you're like wanting the least amount of work, I guess you're rooting for only 2 terms, because then you just look for difference 2 squares after you do the greatest common factor, and you're done. Now I'm looking at this next problem. 5x to the 4th plus 5x squared minus 20x equals 20x cubed. And first thing I notice is all the x's are raised to different powers. So, and 1's on this side, so I've got to move this over by subtracting 20x cubed over. So when I do that, that's going to leave me with 5x to the 4th. And when I subtract that 20x cubed over, my x cubed should go next. So minus 20x cubed, that's from this side. I subtract it over, plus my 5x squared, minus my 20x, equal, oops, sorry about that, equals 0. All right, so now notice I've got these 4 terms right here, okay? And those 4 terms, I've got to start by pulling out a greatest common factor, but then after that, I'm going to have to look for factor by grouping, form factoring, and difference of 2 squares. So what goes into 5x to the 4th, negative 20x cubed, 5x squared, and negative 20x? Well, I can see 5 goes into 5, 25, and 20, so 5. And then x to the 4th, x cubed, x squared, and x, they each have an x, okay, at least the x to the 1st. So I'm going to take that out as my greatest common factor. 5x times what is 5x to the 4th? That's x cubed. And 5x times what is negative 20x cubed? that is negative 4. So 5 times negative 4 is negative 20 and x squared. Oops, don't close that there. And then 5x times what is 5x squared? That is x. And then 5x times what is negative 20x? That is minus 4. All right. And so my next step would be actually to look at my groupings, right? And so if I think of this, and I'm going to make these parentheses into brackets because I'm about to insert more parentheses, and I don't want to clutter parentheses here. So I'm going to put parentheses around my first two because I'm going to try factor by grouping and see if those groups will work. Okay, so what comes out of x cubed and negative 4x squared? Well, I can take an x squared out of both of those. And when I do that, I'm going to be left with x squared times what is x cubed? Well, that's x. And x squared times what is negative 4x squared? That's minus 4. Okay. And then what comes out of x and negative 4? Well, nothing does. Okay, I have this 1 hanging out here. So really, I've got to just bring that plus 1 down. Okay, because I can't just leave it blank. All right, that's a placeholder there. So we have our x minus 4. But notice about that, and I'm going to put my bracket back in, and my 5x on the outside again. All that stuff dropped down. But notice in here, the common binomial is x minus 4. Okay, so that x minus 4 is going to come down. And then I'm left with the stuff in red there, the x squared plus 1. So that also comes down. The other piece that falls out of that is that 5x. Okay, that piece just drops down as well. And all of that equals 0. So what does that mean? Well, it means I have 3 factors. I have a 5x, an x minus 4, and an x squared plus 1. And those 3 things multiply to make 0, which means 1 or 2 or all of them have to equal 0. So I'm going to set them up. 5x could equal 0. If that's the case, x would be 5 times what is 0? Well, 0. That's one solution. X minus 4 has to equal 0. Well, if that's the case, x equals 4. You know what I didn't do? I did not test. There are 2 terms here and here. I did not test for the difference of 2 squares. I apologize, but I'm going to show that at least. Not a perfect square. This is a perfect square, but notice it's different. It has to be minus. This is not a minus, so it doesn't work. So, no harm there. So we keep moving on. X squared plus 1 have to equal 0. Well, what happens there? Well, I subtract 1, so I get x squared equals negative 1. And then I take the square root. So x is equal to, remember, whenever you impose a root or you put a root in, you have to put plus and minus in front. So you're saying plus and minus of the number, remember, square root means what number times itself multiplies to make negative 1. Well, you would think it would have to be negative, but negative times negative gives you positive. Okay, there's no actual possible way to use a real number to multiply and make negative 1. In fact, you can't take the square root or an even root of a negative. This gives you no real solution for this part because you can't have the root of a negative. Okay, that's not possible. All right, so this part we just ignore here. We can't do anything with that. So my solutions, x equals 0 and 4. Okay, those are my 2 solutions. Set notation, or you can just leave it like that. Okay, yep, that's all I got for you, I think. Yep, good lucky.